Measures of center and typical value by Ms. Hedrick, spring of 2019. The goal of today's lesson is to be able to define and solve for mean, median, and mode, as well as use these points to determine the most typical value within a data set. Let's go ahead and look at the agenda. First, we will be reviewing the definitions and ways of solving for mean, median, and mode. We will then practice solving. Thirdly, we will discuss how to identify the typical values on a data set. And lastly, we will then practice identifying the typical values within a data set. Let's go ahead and start off with mode. The mode is the most frequent data point within a data set. So if you look over here at this is a dot plot, you will see that there were 3 people who had 1, 2 people who had 2, 5 people who had 5, and 2 people had 9. And what this was an interview of how many quarters a person had in their pocket. And as you can see, 1, 2, 3, 4, 5, 6, 7 people were interviewed, and this was how many quarters each person had in their pocket. So 3 people had 1. So if you look at the dots, this would tell us that the 1 was the most frequent data point within the data set because 3 people only had 1 quarter in their pocket, and none of these other values can beat that. So the 1 would be our mode here. Is it possible that a data set could have more than one mode? So if you look here at the data set that you also just looked at in your Edpuzzle question, you will notice that the data points 1 and 15 are tied. Both of these have 2 for the interval. So, can it be tied? There is no other data points that top this for frequency. It is possible, yes, to have more than one mode. Whenever you have a tie in frequency with the given data, we call that a tie, and they both are considered the mode, So within the data set, this is just these points written out. 1, and then there was a second one here, 9, 10, 15, and 15. The mode would be 1 and 15 as there were 2 1s and 2 15s tied for the highest frequency. Now we will look at the median. First, I'd like you to look at this image on the right. What we will be looking at here is the height of these orange slices from top to bottom. So let's go ahead and look back at the median. The definition of the median is when the data points that we are given are in order from least to greatest. If you look back at our image here, you will see these are in order from least to greatest, smallest to largest, 10 centimeters, 12 centimeters, and 14 centimeters. So when finding the median, we first have to order our points from least to greatest, and then we find the middle value. So when looking here, we have the points ordered from least to greatest, and then we would find the middle value. So I'm going to cross one off on this side, one off on this side, and then I'm left with the value in the middle. So for this data set, 12 centimeters would be my median. Let's review. So when solving for the median, the first thing that we should do is order the data set from least to greatest. So here are original data points, and we need to order those from least to greatest like this. Once we've ordered them from least to greatest, it's important that we find the middle value. To find the middle value, we can simply cross off from each side until we're left with 1, like this. You could also cross off in 2s, 1, 2, 1, 2, and I'm left with 15, which should have been the median that you got on the previous question. I would now like to show you those data points that we just looked at represented on a dot plot. On a dot plot, you could pull all of the points off and you could list them out and find the median, or you could simply cross them off on the dot plot. Same way we did before. I'm actually going to go ahead and cross off by 2s. 1, 2, 1, 2. Don't forget to go up though. 1, 2, because all of these are 13s. 1, 2, and again, I would be left with 15. On the dot plot, I wanted to show you because again, it's important to remember that this would be 3, 13. So it would have been 9, 10, 13, 13, 13, and it's important that we cross those off before moving on to the 15. Now we'll take a look at the mean. The mean is the calculated average of all the data points. The mean is typically found by first adding all of the data points together. That would look something like this. So 1 plus 1 plus 9 plus 10 plus 15 plus 15, which would equal 51. The second thing we do is then divide by the number of data points. So I would then take and count how many data points I have. 1, 2, 3, 4, 5, and 6. So it would be 51 divided by 6. 51 being how much all of these add up to, divided by the total number of data points. When I do that, I get 8.5, which is the mean or the average of all the data points.
In a second, you will be asked to complete an activity that requires you to use a digital manipulative. We will be using cubes. You will be given a link that will take you to a website that looks just like this. You will come over to where it says manipulatives, click here, and you will have to click the arrow to scroll down until it says connecting cubes. Once you click that, this will appear. To use the cubes, you will just drag and release. If you want to connect 2 cubes, you'll grab another one and attach it like this. If it does something weird like this, they are not connected and you'll have to move it a little bit like that. And once you see this, a little magnifying glass, they are now connected. So you will go ahead and do that. I recommend making stacks of the same color because you will be asked to represent different data points using the cubes. So this would represent a data point of 3 because there are 1, 2, and 3 cubes. So I'm going to take a second and make some stacks. As you can see, I've now made some stacks of cubes. If I were to want to separate these, I would have to click on the little magnifying glass because right now they're all connected. If I click on one of them, it's going to move the whole stack. To just move one, I have to click here and then it will let me. I can also change the color once it's only one single cube as well. The same goes for deleting. If I click on this, I can click backspace or delete and this whole section will be deleted. If I just want one cube to be deleted, I have to separate it and then click the backspace or delete. In the next activity, you'll be asked to represent the data points and then make equal stacks. So you'll have to leave the number of stacks you have, in this case 1, 2, and 3, and I'd have to try to make equal stacks using the cubes I have. So manipulating these cubes so that all of these stacks are equal to one another. Have fun and please feel free to rewatch the video if you need any help.
There are a few ways that you could have completed the following activity. One is once you had your stack showing the data points 2, 1, 2, 3, 3, 6, and 6, it's possible that you moved one cube at a time from the bigger stacks to the smaller stacks until each of your data points was equal. And if you did that, you should have gotten 4 cubes in each stack. And there's 5 stacks, 1, 2, 3, 4, 5. So you should have had 4 cubes in each stack. Another possibility would have been to add up each individual cube. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So you would have had 20 cubes total. And then you could have divided by the number of stacks that you have, or the number of data points, 1, 2, 3, 4, and 5, as we talked about earlier. So if you took all 20 cubes and you divided it by the number of stacks you had, you would have gotten a value equal to 4, which again is the same answer we had on the previous way of doing it. It is important to understand that the mean essentially requires us to move the data points until we have equal stacks. With that in mind, if we had a data set with a number that was much larger or smaller than the other numbers in the data set, could it create a mean that is not accurately a measure of the data? So remember, we want the mean to be the average, so it should be another measure of center, sort of like median. and it should tell us kind of like the middle of the data set. So do you think, right now these numbers are pretty close together, 2, 3, and 6, these values. But if we had one that was very small or much larger, how would that impact the mean? Considering the data set that you just used to complete the mean activity, I have replaced one of the 6's with a 21 on the dot plot. So now you have the data points 2, 3, 3, 6, and 21. 21 would be the outlier here as it lies so much higher than the rest of the data. The mean would now be 7 instead of 4. Notice how much this one number impacted the mean. The new average of the dataset lies higher than 4/5 of the data, being a misleading representation of this data. Remember, mean, median, mode are all supposed to be measures of center of the dataset. In this case, 7 is now not the mean 7 is now not representing the middle or the center of the dataset, as it's far above most of the data points, making it an inaccurate measure of this dataset. Here's a dot plot that represents the boxes of chocolate sold by students in 3rd grade. So each of these numbers is the number of boxes sold, and the amount of dots tell us how many students sold that number of boxes. We are going to start talking about typical value, and the typical value is kind of like the value that most of the data points reflect, if you will, or the typical value can change based on different pieces of a data set. But if you were asked, what is the typical value here? What do you think it would be? The mode of 1, the median of 8, or the mean of 9.5? Now I'll help you to understand what the typical value should be. So if I said what's the typical value here? If we look at the mode of 1, only 5 data points are represented here. There are still 15 data points all the way over here. So I wouldn't say that it was typical that a student only sold 1 box. So for this example, I would not select the mode. So now we have to look at median and mean. The median is 8. While again, this is getting a little bit closer to what was typical, there are still a lot more data points over here than over here on the side of the mean. Now I'm going to go ahead and look at the median. Now I'm going to look at the mean of 9.5. This seems to be in the middle of the majority of the data points. As well as if I count on this to the left of the mean, I'll find that there are 10 data points. And if you were to count all of these data points to the right of the mean, you'd also find 10. So it seems that the mean would be the best measure of what was typical for the student. So it was typical that a student would buy around 9.5 boxes of chocolate. Here's another dot plot that represents pieces of candy eaten by 5 friends. So there was a pile of candy and each student was asked to eat some, and 4 of the students ate 1 piece of candy, and then one student or one friend ate 19 pieces of candy. So I want you to think, what is the typical value here on this data set? The median and the mode were both 1 and the mean was 4. Which one of these values, there could be more than one, represent what was typical? What was the typical amount of candy eaten by the 5 friends? It wasn't typical that the students ate 4 pieces of candy, as the majority of them actually ate less than that, so I wouldn't say it was the mean here. If I said what was the typical amount of candy eaten by the friends in this chart, we'd say 1, either mode or median. And the median is typically the measure, the number in the middle of the data set once they're ordered from least to greatest. So considering that this should be representation of the middle, we might be better off to say the mode, the most common factor, was the most typical value here, but either median or mode would be correct. Just considering those definitions, mode would be a clear representation, the number with the highest frequency, as 1 does seem to be the most typical value here, the most typical number of pieces of candy eaten by the friends. Awesome job! I hope you enjoyed this lesson. You should now know how to define and solve for mean, median, and mode, as well as how to select the typical value within a data set.